Okay, so today we're going to be starting off topic 5, which is all about ratios and rates. And today we're going to be jumping into lesson 1, which is how to write ratios to compare quantities. So, first off, what is a ratio? So, a ratio is a relationship in which for every x units of one quantity, so for every x of one, there are y of another quantity. And so a ratio can be written in 3 different ways. So the way that we say ratio is we say x to y. This is one way that we can write a ratio. The second way is we can write with a colon, and it still reads the same, x to y. And the third way is to write in fraction form. And again, you say x to y. So these are the 3 ways that we can write ratios. And in a ratio, the x's and our y's, these are all called terms. So the x and y in a ratio are terms. So example 1, let's put this into an example to make a little bit more sense of this. So example 1 says, Tom's pet service takes care of cats and dogs. Currently, there are more dogs than cats. It wants us to compare the number of cats to the number of dogs, and then compare the number of cats to the total number of pets at Tom's pet service. So let's use a ratio to compare the number of cats to dogs. So what this is saying is that for every 14 cats, there are 17 dogs. So we can write this as 14 to 17. We can also say 14 to 17 fraction form, or we can just write 14 to 17. So those are how we would compare this in ratio form. So for every 14 cats, there are going to be 17 dogs. Now it asks us to use the ratio to compare the number of cats to the total number of pets. So if there are 14 cats and 14 dogs, what's our total number of pets at the service? So if we have 14 cats and 17 dogs, total we're going to have 31 animals. So now it's saying before we compared cats to dogs, and now we're comparing cats to total number of pets. So we still have 14, but now we have 14 to 31. I can also put this in my fraction form, or I could just write out 14 to 31. All right, so I want you guys to try this now. So now I want you guys to try what are three ways you could write the ratio of dogs to the number of total pets. So remember, with our total pets at this service, we have 31 total pets, and the amount of dogs that we have are 17. So I want you guys to write 3 ways of dogs to total number of pets. So if we're saying dogs to pets, we're going to have 17 to 31. I can also write this with my colon, and I can also write this in fraction form, 17 to 31. So for every 17 dogs, there are 31 total pets. All right, let's go to example 2. The ratio of footballs to soccer balls at a sporting goods store is 5 to 3. So 5 to 3, 5 to 3. If the store has 100 footballs in stock, how many soccer balls does it have? So I'm going to show you guys 2 ways that we can do this. Number 1, we can draw up a table or a number line. I drew a little table for us. So what this is saying is for footballs, we have 5, and soccer balls, we have 3. And so one way that you guys could do this is you could actually go ahead and count up. So 5, we're counting by 5s, and the 3s, we're counting by 3s. We could literally go all the way up until we get to 100. 3, 6, 9, 12. We could literally go all the way up until we get to 100. The other way that we can do this is through cross multiplication. So if we have our fraction form, we have 5 to 3, and we have footballs on top and soccer balls on the bottom. We want to set this equal to our second ratio. In our second ratio, we know we have 100 footballs, and since footballs are on top, and then put 100 on the top. And on the bottom, we don't know how many soccer balls there are when there are 100 footballs. So to solve for that, we can use cross multiplication, or what's called the butterfly method. So I just draw little butterfly wings. And so what I'm going to do is I'm going to do 100 times 3. And I'm going to set that equal to 5 times, and since it's an unknown, I'm going to use a variable. In this case, we're doing soccer balls, so I'm just going to say S. 5 times S, or just 5S. So 100 times 3 we know is 300. I'm going to set this over here. More room. So we have 300 equals 5 times S. And hopefully you guys remember from our last unit, when a number is right next to a variable, this means to multiply. And to solve for my variable, to get my variable by itself, I'm going to undo that operation. So what I'm going to do is 300 divided by 5. And so when I do 300 divided by 5, I'm going to get 60. And so that means that for 100 footballs, I have 60 soccer balls. I have 100 to 60. You also could have found this answer if you would have kept up with the pattern in the table too. So if that makes more sense, counting up that way, you should do that, or you can do the cross multiplication method. So again, in cross multiplication, you multiply the opposites and set them equal to each other. So 100 times 30 were opposites, and then I set that equal to the opposite, which was 5 times the unknown. So I multiplied that with a variable, and then we can undo the operation to solve for the missing variable. All right, let's practice one more. So example 3, Shen can ride his bike 3 miles in 15 minutes. So what this is saying is we have 3 to 15, or 3 to 15, or 3 to 15. At this rate, how long will it take Shen to ride his bike in 18 miles? So again, there's 2 ways that we can do this. One, we can make a table. We can say miles to time. So for every 3 miles, 3, 6, 9, 12, 15, I need one more, 18 to get to 18. And then I can go with my time. So my time is going up by 15 minutes each time. So I can just fill up this table by going up by 15. So I know that that would be 30. I know it would be 45. And then 60, 75, and 90. So I just found out that in 18 miles, it would take me 90 minutes to ride. The other way I could do that is to set my cross multiplication. So I know I have 3 to 15, and my 3 represents my miles, so miles are on top, and minutes is down below. I'm going to set that equal to my new ratio, and it's giving me 18 miles, and we know miles goes on top, so I'm going to put 18 on top. And my denominator, we don't know how much time is going to be yet. So I'm going to use a variable for that. So I'm just going to put T for time. And now I'm going to use my cross multiplication method. So I'm going to go across 18 times 15, set that equal to the other side, which is 3 times T, or just 3T. And now by undoing the operation, when a number is right next to a variable, that is multiplication. So to undo multiplication, I'm going to divide by 3 on both sides. Oops, first I need to multiply. Oops, okay, first I need to multiply 18 times 15. So we have to do 18 times 15, which is 270. And I'm going to set that equal to 3t. My apologies. And now I can undo the operation. So now I can say, okay, 3t is multiplication. So to undo, I'm going to divide by 3 on both sides. So 270 divided by 3 is 90. So my time would be 90 minutes. So 2 ways to find that, either using the table method and trying to find the pattern, or using our cross multiplication, whatever makes the most sense there. So again, ratios, there's 3 ways to write them, either with our words, the 3 to 15 fraction form, and with our colon, and knowing what the relationship is between our x and y, between our terms, can help us to find an unknown in a scenario.